of the day, Colin Hammond, who will be talking to us about what is requirements quality. Colin, over to you.
Thank you. Thanks, Beth. Well, they're two very hard acts to follow with Beth's and Simon's talks, and I'm particularly jealous of Simon's colourful slides. So for those, well, it's been a while since I was in London, and I thought I'd wear a suit today to fit in. That was a foolish assumption, and that's quite often what we do with requirements. Actually, is we make assumptions. So there's a theme there. There's a theme there going on. Let's just remind ourselves about what is a requirement. This is one of many definitions of what a requirement is. It's about communication. It's about being clear about what we're going to do about value. Robin Goldsmith, if you haven't heard of him, he's the author of a book about business requirements. Excellent speaker and author on that subject. So requirements is not just about user stories. Is there actually a hierarchy to them? There's different terminologies for these things. What we typically focus on is, and they are all really interrelated, but we typically focus on user stories. Now, my own journey in software started off in the 1980s writing Excel programs. We didn't have Visual Basic in those days, but anyway, programs with spreadsheets, and I've kind of done all roles. Programmer, analyst in those days, developer, tester, and then I spent most of my career as a project manager. And as a contract project manager, I would go from project to company, where they give us the hardest project usually the basket case project, and they say, follow all these procedures, hands tied behind your back, and deliver. And if you don't deliver, you're out. So I had to learn really quickly, what do you need to do to be successful? And one of the techniques I found was actually focusing on the requirements first, paying attention to requirements, and are the requirements good enough, is a really good challenge to the business. Is are we ready to deliver? Are we going to deliver successfully? So on the theme of communication and what is a requirement? Well, this is the typical journey of a user story. Is that the product owner or BA will write a user story, and we've analysed. Come on to how we do that in a minute, but we've analysed nearly 250,000 user stories from hundreds of companies now. And what we found is the average size of a user story is 12 words, and it actually has a functional size as well, which allows us to get greater insight into defects and defect potential and stuff like that. So product owner and BA, product owner and BA writes the story, then gets read by a tester, a couple of developers, stakeholder, and other users. And the point of it is to communicate this: what is it we need to deliver in order to present value to the customer? Now, in those 12 words, and that's an average, they do obviously vary a lot. When there's a business requirements document, which is quite verbose, or something really succinct, like a couple of words, maintain user profiles or whatever, there is a potential for miscommunication. And if that tester, when he reads that user story, says, yeah, I think I know what that means, but makes one little mistake in their assumption, a bit like me in the suit, right? If they make one little mistake, that mistake can lead to rework or bugs later on. And then the same happens when the developers read this user story. And this is why we have refinement, so they get everybody around the table, the three amigos meeting, to make sure that everybody has a common understanding. With all this remote working, actually, there's still more creeping in of potential misunderstandings of user stories. And furthermore, if there is a lot of churn on the team, the person who wrote the user story had one frame of reference and background knowledge, and then the readers, they all start to make it like me in my suit. And each one of these will create rework and bugs. And so that's really what requirements quality assurance seeks to challenge. Can we avoid bugs? Can we shift left? Can we prevent bugs from even happening through improving the quality of those requirements? Now, and this is why. So we're going to talk about what requirements quality assurance automation is. but also why. The reason we do this is because fixing defects in requirements or fixing defects anywhere in the life cycle late is extremely expensive, and it's not a linear thing. And you know, if you've seen production defects, and they're always almost every week in the paper, there's a production defect that causes a major corporate, maybe even existence threatening event. Fixing these defects late, and there's a high proportion of them are caused by poor or incomplete requirements. So bit of participation now. Can you put your hands up if you spend more than 5% of your time, if you're a tester, more than 5% of your time clarifying requirements and checking that you've understood them correctly? You mean more than 5%, more than 10%, more than 20%. Okay, so we come down around about 20%, more than 50%. There's a couple of nods. Yeah, three. And we've spoken to a number of, thank you. We've spoken to a number of organizations where the test team are spending 50% of their time going back to the authors of the user stories or the requirements, product owners, just to verify their understanding of that requirement. That's really wasteful. If only they spent a bit more time on those 12 words, or maybe added a few to clarify them. That conversation, that toing and froing could have been avoided, and the waste of time could have been avoided. And remember, the developers need to do the same thing, or do they leave that to the testers to get the requirements qualified first, refined and improved first? So it is a problem. Requirements defects is a problem. Now, for those of you that like numbers, there's some detailed studies on, oh, look, there's a defect in my work here, look. Yeah. So whenever we do knowledge work, actually it's a really good point, because whenever we do knowledge work, we actually make mistakes. And what this is saying is that for any given set of functionality that we're delivering, there will be, by its nature, there will be some defects to requirements, some in the architecture, some in the design. Now, obviously, the highest concentration is in the code, so it's 1.15 defects per function point. And these are averages based on point system. I'm not going to describe function points, are just a measure of size, okay, functional size, but quite a useful one. And if you're interested, ask me later how you calculate this. The message here.
Sorry, can't see the writing small. Is that Kipper Jones that you have in there?
It is, yeah. The message here is that the defect potential, if you add up 0.7, 0.1 and 0.95, you get a bigger number than 1.15. But most of our time we spend testing code. How much time do we spend testing requirements, architecture and design? Things to reflect on, as the previous two speakers spoke less about testing and more about quality. It's end-to-end quality, and that's what this is really. Take one thing away, hopefully that's the message. Is quality is about end-to-end, and it starts with requirements. Another way of looking at this is, what is the root cause of defects found in production? So if you do root cause analysis on the defects that you've exposed, studies will typically show, and these vary enormously, especially depending on the size of your project. Most of our work most testing work in most organizations is not about end-to-end quality. It targets, does the code match the requirements? In actual fact, when we look at root cause of defects in production, it's the requirements themselves that are faulty. And in the case of Accenture reported a couple of years ago that as much as 35% of defects found in production were caused by incomplete or incorrect requirements, 35%. So my own journey, now here we are onto requirements automation, now you know why, is that as a project manager, I found knowing functional size, function points of a system or project to be really useful. And I thought, could I automate that using natural language processing? 6 years later, the answer is yes, and we've done a lot of it. And the quality assurance dimension actually came as a byproduct of measuring software size. It wasn't that we set out to do quality assurance. That was more of a mistake. So first of all, we need to establish what is a good requirement, and there are different standards for this, and I wouldn't call this a standard, it's more like a guideline. But what we found is that actually this is a little bit old-fashioned and perhaps not applicable in all places. This I find negotiable and estimable to be a little bit vague. That is our favorite list, and it's not to say it's right or wrong, but that is our favorite list. And the reason there is ticks next to 9 out of 10 of those is because the textual analysis that we do on requirements is able to help find defects in the requirements according to 9 out of 10 of those characteristics. So in spite of what Simon says, we can actually determine whether a requirement is testable or not completely. And you'd still need to have a conversation around it, but we can have a first stab at it. We'll have a look in a second at how that works. By the way, the one we can't tell you about is valuable. We cannot tell you if that requirement is valuable to you in your business. So is it a high priority or not? So the tool that we've created will read the text of user stories. Functional intent, it detects users, it detects the user's interaction with the data. It uses the wisdom of experienced requirements quality engineers, such as Linda Westfall, Carl Viegers, Joy Beatty, and others, to really test for language patterns that are known to be vague, ambiguous, or lead to defective requirements or unhelpful requirements. Unfortunately, I mean, the English language is incredibly powerful and incredibly flexible. The challenge is that actually good software requirements are not flowery Shakespearean English, they're actually quite dull. And the dull ones are usually the ones that are clear and easy to deliver. So we generated this tool that sort of goes a little bit beyond just requirements QA. And automated requirements QA is a subset of what our analysis does. So if you take this example of a user story, a waiter in a restaurant taking orders from a table. I'm not saying it's a well-written user story. It's just a version of it. First, validate the device. So he's going to take your order at the table with this device, validate my permissions. Then as a waiter, I can create an order. It's just a version of this user story. And what the tool that we've created will do will analyze every word of that phrase or of that sentence. Oops, was in long here. In order to detect the functional intent. So who is the user, which is the waiter, not showing there, keeps jumping. The 3 functional steps, and then the actual data movements. So the ER and X there stand for entry, read, and exit. Now, if you're working in a multicultural team where English is the language of the user stories, but it's not the first language of every participant, stop. There we go. Having a functional interpretation of that user story, and it may not be the right one, but it's a functional interpretation. There we go again. Didn't mind the pause button, interestingly enough. Defect in this software. This brings everybody on the same page. So whether it's right or wrong, everybody is on the same page about what is the functional intent of this user story. And that in itself eliminates misunderstandings. So then we go a step further and we use that wisdom of those bright requirements engineers, such as this guy here, to give you, think Sonar Cube for requirements. Sonar Cube for code, this is like the Sonar Cube for requirements. It gives you feedback, fast feedback on your requirements. It doesn't do everything, and we're on a journey of making this a richer, more powerful, more flexible capability of helping you write better requirements. This is a reminder of one of the guys' wise input to some of the tests that we do on requirements. And people often forget that if you don't get the requirements right, you're kind of wasting your time having fantastic code doing the wrong thing. So in the true essence of Agile, it's all about fast feedback loops. So the tool will analyze those requirements. And if you were sitting in a Three Amigos meeting, discussing user stories, trying to clarify them, make sure that they're testable, user-oriented, sizable, and so on, that's a really good meeting. And I know of one bank that has all 30 people every 2 weeks, spending half a day discussing user stories. It's a really expensive way of finding them. So we can't find all of them with the tool, but we can find some of them, and it's ridiculously fast. So that is particularly helpful. Now, as we're in a community of testers today, not only can we identify the functional intent of that user story, we can propose tests for it as well. And these are available in 3 different formats as a flow. So green is the happy part of testing. Red is obviously some negative loop testing. And the merit of this is these tests are 100% necessary and 100% traceable back to the functional intent of those user stories. It's not all the testing you need to do. Absolutely not. But it's a good start. It's a good start, and it's a good checklist. So if you haven't already picked it up. But furthermore, we can also auto-generate, we call them pseudocode for regression test scripts, and these match that functionality detected in each user story. So these are sort of really the starting point of a regression pack, which you can embellish with more details later on. So that's really good. That's one individual testing an individual user story. But where it gets more exciting is when we start testing sets of user stories. So hopefully this will work. There we go. So if you put a whole backlog into the tool, it will go through each one of those user stories one by one pretty quickly, doing the natural language processing on it, running a lot of cross comparison of each story against all the others, detecting the functional intent, sizing it, and finding defects. Now, what we have here, for 231 stories, I'm not going through all of this, but 231 stories, it's found 352 defects across those stories. Actually, it's found more, but we're just not reporting them all. Typically, with the Three Amigos meeting, the average is about 45 minutes to an hour to find and fix a requirements defect. So what we're doing here is we're saving a lot of time, quite a lot of time. And the bigger the set of the requirements, the more valuable, the more effective and efficient this is. So this is the message we talked about earlier. Probably slides in the wrong order, apologies for that. But once we've been through a set of requirements, we can then produce a report. And this is particularly useful from a quality point of view, feedback to the organization about why quality matters and why quality early matters. If your set of requirements scores low, and we have to give several quality scores, but essentially it's 1 per requirement. So there's a quality grade per requirement, plus as a quality grade for the overall set of user story set of requirements. And if the requirements are bad, then you want to push them back and say, come on, refine these until we're ready to start building. And that will prevent bugs from getting into the system. But it gets quite exciting. At least I get excited about this stuff. I never knew my career would end up getting excited about user stories and science. When it's scanned a whole set of user stories, it can pull out who the users are. What are the terms we've used for objects? It is brilliant at trapping inconsistencies. If you've got multiple BAs and product owners working on the same set of requirements, or over time they evolve, then this will expose that really quickly. Now, you may be familiar with it. It's a little like this. And what's quite tricky with this is to really get the essence of what those user stories are telling us. And you can get kind of lost in the words. Great tool, but it has some limitations. And what our tool can do is expose that user object interaction. So it will generate this diagram. Now, for those, it's quite hard to see. The blue blobs are the users, and the gray blobs are the data terms, the terms used within the phraseology of the user story for data. And then on each one of these lines is the verb that associates the user with that object. So what we can see here is a map, if you like, of an entire set of user stories from which we can discern all sorts of insight about their completeness, their quality, their consistency. Things like all these user stories have got an ambiguous, I should point down here, I've got an ambiguous term used for the user, but functionality was detected within the language of them. So we could just dive into those, correct that, fix that problem with those user stories, make sure we've got a user identified for them. Up here on the top left, we've got lots of arrows pointing to a single box. That tells us we've got complex requirements related to that term. In this case, it's something called care circle. It's actually a real set of requirements. And so we already know from analyzing these requirements that we have complex requirements around care circle. Therefore, we're likely to have complex code. Therefore, we probably want to have high test coverage around that object, that set of data. So already we're getting insight into how we can plan our test strategy simply by looking at the density of lines on this diagram. So a whole load of other things it exposes. Obviously, we've got some outliers here on the right and on the top. That's telling us something. Either we've got an incomplete set of requirements, or it's telling us we have inconsistency of use of terms. All of this helps to give us fast feedback on the quality of those user stories so that we can refine them faster and then start working with a better set. CRUD analysis is, anybody not familiar with CRUD analysis? Too shy to stand up. Create, read, update, and delete. It's the notion that all data within a system should have at least one create, one read, one update, and one delete. It's a traditional business analysis technique. It's very useful because it makes sure that we understand where there might be duplicate functionality or where there might be omissions or missing functionality. Doing CRUD analysis on a small project, doing it on a large project with a large set of user stories, it's really, really difficult and difficult to maintain. It's got it for you. And it's all traceable right back to the individual user story, so that if you click on where it says missing, it will even propose what the missing story is, solve that problem for you, and then this table will update. So I'm not going to wait for that to end, move on. So coming towards a summary, really, what is automated requirements quality assurance? Well, we do it at two levels. We do it at the individual story level, where we get all this useful feedback. And then we do it at the set of user stories. And it's really at the set of user stories where it gets exciting, because we can all have a checklist. Say, well, each user story must, be clear, concise, complete, and so on. But when it gets to sets of user stories, interpreting them collectively is really hard. And this journey that we've gone on to sort of see what we can establish and see what kind of insight we can get from a user stories actually reveals great amount of value. We're doing some work for the Western government at the moment. They have a massive project to roll out an HR system. 2,300 user stories they gave us. In less than an hour, we found 3,000 defects in that set of user stories. 3,000 defects. Now, finding defects is normally quite time consuming. And what they now know straight away is that if they start building that software without fixing those requirements defects, they will build the wrong thing. If they build the wrong thing, and it's at such a massive scale, if they build the wrong thing, they'll have to do it twice. And it'll be more expensive the second time round. So the amount of money per day that they would waste by not fixing those requirements is eye-watering. It's hundreds of thousands per day by not fixing those requirements. So Scope Master hasn't fixed them because it only gives you feedback on the stories. but it's an extremely valuable, especially on large projects, extremely valuable insight into. So kind of in summary, requirements quality, automated requirements quality assurance is a subset of requirements quality analysis. Analysis can also give us insight into functional size and generate the test scenarios, but the quality assurance is really about what can we do from those requirements as early as possible. So shift left. So moving for time. Okay for time. Questions?
Is it configurable in any way so that you can say, I don't want to know about things that look like this, defects that look like that, because that doesn't fit with our, we don't class that as a defect. So I'm actually more interested in these things. Does it have that aspect to it, or?
At the moment, it's a fixed testing structure.
Yeah.
But the ability to sort of like customize the tests is coming. Yeah.
Great, thank you.
You see yourself making use of AI to automatically fix the requirements?
At this stage, so we use a natural language processing model. It is fixed. And so you put the same requirements in, you get the same results. We've been asked a lot about large language models and ChatGPT and OpenAI and all that stuff. And the first step is to actually give the feedback to the team. How might these requirements be interpreted? And actually, we don't need to get too far ahead of ourselves too quickly, because actually it's the BAs and the product owners that have that knowledge that need to make a judgment as to whether this user story can be improved, should be improved. What we're saying is this is how it might be misinterpreted. It's up to you to rewrite it so that it gets interpreted well. Now, we will be adding some additional functionality whereby it would suggest what a better story might be. But that will be very transparent about where we are using that AI so that it's done in a responsible way and transparent way. So.
You mentioned that requirements should ideally be design free. Quite often user stories in practice are very biased by the design of an existing system that they're using, and they specify their requirements relative to that. So how does the system kind of pick up on these design characteristics of the requirements?
So really, there should be, for all even changes to existing systems, there should be a user-oriented statement about that requirement. What is it the user needs to achieve? Now, maybe the next level of granularity says, well, we're living in a constrained world, and this is the existing design, and this is how we need to modify the design. But there should still be a user story that describes it from a user perspective. So we do call out anything that looks like design within the user story, specifically to encourage you to think about, and a lot of pushback we get from this is, oh, we have to rewrite our user stories. And the answer is, going forward, yes, you might, because it's really important to have a user-oriented statement.
So is that explicit in the report? Is that aspect
Yes,
design
yes.
that's in?
Yes, it specifies it, tells you what you do.